working on AI RAN for about 5 years now with NVIDIA. A couple of years ago, we've started to show how we could put AI applications and RAN workloads on the same hardware. This year, we're showing some of the fruits of that. With working with SoftBank and NVIDIA, we launched a small trial with SoftBank in Japan at the end of last year, and we've got a couple of demos on the stand where we're showing the importance of having low latency. So showing examples of applications where you really need access to that low latency of having the same AI application run on the same hardware as the vRAN software, and showing that. The other piece of it that we're showing is lots of improvements on what we can do in improving the performance of uplink. So specifically, we are looking at things that we can do to use sort of image processing techniques and applying those techniques to channel estimation error to improve uplink performance. Now, in theory, that kind of algorithm has always existed, but we've never before had access to the high computational capabilities of the NVIDIA superchips. So now that we have access to that, we've worked with SoftBank to make that a reality, put the algorithms into place onto real live working hardware, and we have it up and running. And we're getting improvements typically around 20%, but sometimes as much as 50% improvement on throughput and the uplink. Well, even this week, we've had one person come in with a use case where they wanted really rapid access for emergency first responders. So let's say there's been some kind of an event or incident. They wanted to be able to dispatch drones quickly to the site and get information and start analyzing information much more quickly. And sometimes it's not just sending a drone to a static site, but then having a drone perhaps follow somebody or follow a vehicle that's fleeing or whatever the situation may be. They wanted that kind of AI capability. But if you've got a flying vehicle and you need to provide instructions quickly, then that's an example of a use case that where that low latency might make a difference. Well, with AI RAN, for example, one of the concerns is, we've got all this excess capacity in the network. What can we be doing with that? Particularly if those are some of these GPU resources that we've got from NVIDIA. We've got huge capabilities here. What can we do with that? So one of the demos that we have here today shows how we're able to link the SMO with the NVIDIA's OCloud Manager. And so we're able to take a pool of servers with GPUs on them, have the SMO see what's happening on those GPUs. So we heard from operators they're concerned about making sure that they've got enough capacity and resources to run the RAN. So we see what resources are used for RAN, how much excess capacity is in the network, and then we can use open APIs to expose those resources and make them available for others to use and purchase GPU as a service on the spot market. So these are existing markets. The operator doesn't have to go off and sell and promote them. They can just make their GPUs available, and others can monetize, others can use those resources, and it gives operators a way of monetizing the excess capacity in the network.